We want to find the area of the shaded region, or the area shaded in blue. We first want to devise a strategy in order to find this area. I think the best strategy is going to be to find the area of these 4 half circles or 4 semicircles, meaning the area here, 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 and finally here. Once we find this combined area, notice how we subtract out the area bounded by the circle and the square, meaning this area, this area, this area, and finally this area, we'd be left with the area of the shaded region. We'll be using the area formula for a circle and the area formula for a square. So the area of a circle is equal to pi r squared, where r is the radius, and the area of a square is equal to s squared, where s is the length of one side. So let's begin by determining the area of the 4 semicircles. When we combine the area of 4 semicircles, that would be equal to the area of 2 full circles. So the area of the 4 semicircles is going to be equal to 2 times pi r squared. Now looking at one of the semicircles, notice how the diameter is equal to 4 units, and because the radius is equal to half the diameter, or this length here, the radius is equal to 2. Which means the area of the 4 semicircles is equal to 2 times pi times 2 squared. 2 squared is equal to 4, and therefore the area of the 4 semicircles is equal to 8 pi. Let's go ahead and label this 4 semicircles. So we'll be using this area again later. Now let's work on determining the area bounded by the circle and the square. And this is going to take a little bit more work. In order to find the area of the circle, we'll have to determine the radius. Before we find the radius, though, we'll need to determine the diameter. And notice how this would be the diameter of the circle, which is also the diagonal of the square. So we'll first find this length, and then find half of it to determine the radius of the circle. Notice how the diagonal of the square forms 2 right triangles, one here and one here. And we can use this to determine the length of the diagonal, which is also the hypotenuse of one of the right triangles. There's a couple ways of doing this. Looking at one of the right triangles, because these 2 acute angles are congruent, they both measure 45 degrees. Whenever we have a 45, 45, 90 right triangle, the lengths of the 3 sides will always be multiples of 1, 1, and square root 2. The 3 sides of a 45, 45, 90 right triangle always hold this relationship. Notice how for our right triangle, the 2 legs have a length of 4. So if we multiply all 3 sides by 4, we'd have 4 times 1 here, 4 times 1 here, and 4 times square root 2, which means the length of this diagonal is equal to 4 square root 2 units. Another way to find this length would be to use the Pythagorean Theorem. Let's also show that. The Pythagorean Theorem states that for any right triangle, a squared plus b squared equals c squared, where a and b are the lengths of the 2 legs, and c is the length of the hypotenuse. So notice in this case, both a and b are 4, so we'd have 4 squared plus 4 squared equals c squared. 4 squared is equal to 16. 16 plus 16 is equal to 32. So we have 32 equals c squared, taking the square root of both sides. The square root of c squared is c. And because 32 is equal to 16 times 2, and the square root of 16 is equal to 4, we have c equals 4 square root 2. So again, this tells us that the diameter of the circle is equal to 4 square root 2. The radius is equal to half the diameter, or 1/2 times 4 square root 2, which is equal to 2 square root 2. Now we have all the information we need in order to find the area bounded by the circle and the square. The area bounded by the circle and the square is going to be equal to the area of the circle, which is pi r squared, minus the area of the square, which is s squared. So substituting in the values, we'd have area equals pi times r squared, where the radius is equal to 2 square root 2, minus s squared, where s is the length of one side of the square, which is 4, so minus 4 squared. Let's show some work on 2 square root 2 squared. 2 square root 2 squared is equal to 2 square root 2 times 2 square root 2. Well, 2 times 2 is equal to 4. Square root 2 times square root 2 is equal to the square root of 4, which is 2. So 2 square root 2 squared is equal to 8. So the area of the bounded region is equal to pi times 8, or 8 pi, minus 4 squared, or minus 16. Again, this is the area of the region bounded by the circle and the square. So now we'll use this area and the area of the 4 semicircles to determine the area of the shaded region. The area we're looking for is equal to the area of the 4 semicircles, which is 8 pi, minus the area bounded by the circle and the square, which we now know is 8 pi minus 16. So to help simplify here, if we want, we can think of distributing a negative 1 because of the subtraction. So we'd have 8 pi, and then minus 8 pi, and then plus 16. Notice how 8 pi minus 8 pi is 0. So the area of the shaded region, or the region in blue, is exactly 16 square units. I hope you found this helpful.